All right, so we begin our session. Unfortunately, due to this delay, whatever time we had, our Director General is unable to start the meeting, but she has virtually given us permission to start. So I would like to start with everybody's permission. So members of the high-level organizing committee, distinguished chairs, speakers, and conveners, distinguished participants from India and from across the world, friends and colleagues, wish you all a very pleasant, distinguished the world, friends and colleagues. Success of our CSIR scientific sessions at the last 3 UN General Assembly Science Summits, we are thrilled to launch our 3rd edition. A warm welcome to all our participants to the CSIR session called CSIR for Connect, Collaborate, Converge, and Convert for Global Sustainable Development. Building on that foundation, it is important to remember CSIR has been contributing significantly to the industrial, societal, and economic growth of India for over 8 decades now. Research and innovation activities of CSIR are well aligned with the UN SDGs. Our session will briefly showcase our S&T interventions and solutions contributing to the UN SDGs and explore pathways to strengthen global collaborations. The event spans 6 thematic days, each featuring talks and discussions by eminent speakers from CSIR, from government, and the industry. The first thematic session, can I have the presentation? The first thematic session is scheduled on 11th September, that is today. It will focus on shaping infrastructure for safer tomorrow. Can we have the first session, please? It will focus on shaping infrastructure for safer tomorrow with discussion through 10 presentations encompassing 2 topics, namely material monitoring mitigation for safe and sustainable infrastructure and climate resilient building and technologies. The second thematic session on emerging environmental challenges, science-driven scalable solutions. It is scheduled on 12th of September at 2:30 p.m., exactly the same time at which we wanted to start today. It will feature 4 talks and stakeholders' perspective. The third thematic session, scheduled on 15th of September at 2:30 p.m. IST again, will deliberate on exploring the ocean, India's path to a blue economy. This will present about 5-6 presentations. Coming to the fourth, are the slides moving?
Yes.
No, coming to the fourth thematic session, scheduled on 16 September at 2:30 p.m. IST. It will focus largely on marine resources for sustainable development. Here also we will have presentations, 3 talks by CSR experts and 3 from the industry partners. The fifth thematic session, which is scheduled on the 17th of September, but at 2 p.m. instead of 2:30 p.m. IST. The session will discuss advanced and affordable medical devices. There will be 7 talks, 5 by the CSR experts and 2 by our industry partner. The 6th and the last thematic session is scheduled on the 18th of September. Will start at 2:30 p.m. IST. It will deliberate on driving gender-inclusive innovation, gender equality, and breaking barriers through CSR case study. It will feature 3 talks by CSR experts and a panel discussion focused on STEM for a changing world. All thematic sessions will be moderated by eminent experts and will provide 6 to 10 minutes discussion and Q&A break. We will conclude this session of CSR event with a closing remark on the 18th September, the last technical session day of ours. This initiative aims to familiarize the global science and technology community with the key technological strengths of CSIR, showcasing its innovative solution driven research and its wide ranging applications for societal welfare while also fostering international global collaborations. We are certain that this informative and interactive meeting will be immensely useful for the global scientific community, startups, industry, policymakers, global think tanks, and other stakeholders working towards global sustainable development. The deliberations would ignite the development of new partnership platforms, new collaboration models, and engagement in policy dialogue, as well as strengthening overall global connects. With this brief context setting, I would once again welcome you all to our scientific event of CSIR. And we now move on to our first thematic session on shaping infrastructure for safer tomorrow, chaired by Dr. N. Anandavalli, Director, CSIR SCRC, and Dr. Pradeep Kumar, Director, CSIR CBRI. With this, I hand over the floor to our Director, N. Anandavalli. Over to you, ma'am.
Ramasamy, esteemed colleagues, distinguished guests, participants, and Ramasamy, participants and structure. These three pillars, advanced materials, cutting-edge monitoring technologies, and robust mitigation strategies together form the foundation for building infrastructure that can safely meet the demands of the current century and beyond. As we all know, infrastructure is the backbone of societal development. Our roads, bridges, buildings, and transport systems enable economic growth, improve quality of life, and connect communities. But with growing urban population, increasing natural hazards, and climate change impacts, our traditional approaches to infrastructure design and maintenance are being stretched to their limits. The theme of today's session focuses on how emerging innovations in material science, digital monitoring, and resilient design can collectively ensure infrastructure that is not just safer but also more sustainable and adaptive. Material innovations form the first pillar in our discussion today. The development and application of advanced and sustainable construction materials, including eco-friendly concretes and geopolymeric materials, not only reduce the carbon footprint, but also enhance durability and longevity. Such materials pave way for the infrastructure that is cost-effective and aligned with the global sustainable goals. The second pillar is the infrastructure health monitoring. Here, digital technologies like sensors, the Internet of Things, and artificial intelligence are catalyzing a paradigm shift. Real-time health monitoring enables proactive maintenance by detecting early signs of distress. This preventive approach is both economical and essential for safety. Let me also emphasize the critical role of highways and expressways, the means of economic activity and mobility. Structural integrity and safety of these corridors before operationalization are crucial to avoid any catastrophic failure in the future. Assessing and ensuring the resilience against increasing traffic loads and environmental stresses is a challenge that demands rigorous scientific and engineering approaches. The third pillar, mitigation, focuses on disaster resilient infrastructure and post disaster management. Climate change and urban expansion increase exposure to risks such as earthquakes, floods, and extreme weather events. Designing infrastructure that are not only withstand but such shocks, but also recover rapidly post event is imperative for societal resilience. Industry perspectives are invaluable to this conversation. The active participation of the private sector helps shapes practical, scalable solutions. Industry leaders bring insights into realistic challenges faced during the infrastructure design, construction, and operation phases, driving innovation that balance safety, sustainability, and cost. So 5C, CSIR for connect, collaborate, converge, and convert for shaping infrastructure for safer tomorrow. The knowledge shared today will offer new pathways for research, collaboration, and policy formulation, contributing towards the resilient infrastructure systems that support economic growth and community well being. Aligning with the Sustainable Development Goals 9 and 11, this session aims to foster innovation and sustainable practices that can be implemented globally. I encourage all the participants to engage actively in the presentations and discussions as we collectively explore these transformative ideas. With this, I'm pleased to invite Dr. M.B. Anu from CSIR SCRC to begin his talk on advanced and sustainable construction materials that promise to shape the future of the infrastructure, before which I would like to quote the wisdom of Tirkural, Pini inmai selvam viளைவு imbam ஏமம் ani என்ப நாற்றுக்கு இவைந்து. Good health, wealth, produce happiness and protection. These five are the ornament of any country. Wealth of any country. Thank you. Monitoring and mitigation for safe and sustainable infrastructure. I'm pleased to invite our first speaker, M.B. Anu, Chief Scientist at CSIR Structural Engineering Research Center. And currently he is heading the Steel Structures and Tower Testing Research Station, CSIR SCRC. His presentation will focus on advanced materials that enhance durability while minimizing environmental impact. Please welcome Dr. Anup.
Thank you, madam, and good afternoon. So I'll be discussing on advanced and sustainable construction materials, as already mentioned by Dr. CRC. The construction industry is one of the largest market in the world, and if you look at India, it's a high growth path, and we are expecting it to become the third largest construction market in the world by the end of this decade. And it contributes largely to the GDP, and contribution is supposed to increase. And the number of government schemes that the government is giving a lot of impetus to the improvement in the construction infrastructure sector, because it is the backbone of the nation. All the other industry and sectors depend on infrastructure for their development. And also when we see the employment, this construction sector employs almost 71 million people, and by the end of this figure, it will go up to 100 million. President is giving a massive push to infrastructure development in the country, including power transmission, roads and railways, renewable energy structures. Go ahead. So we are talking about how important is the construction sector for our country's development, and there's a large scope exists to develop different technologies. And the major challenge because the construction sector is that this sector contributes the highest to the greenhouse gas emissions. If you point of view of sustainability, construction sector contributes almost 37%. And in that, major impact is coming from the production of steel and concrete, which are the most commonly used construction materials. And now we have commitments of net zero carbon emissions by 2075. Our government is committed to that. And this indicates that we have to have a paradigm shift in this sector on the use of different types of materials other than steel and concrete. Can we go for how to optimize this material, like more resource efficient materials, modular or prefabricated construction, low carbon materials, energy efficient design, end of use strategies, how to recycle the materials, and on-site renewable energy. So see, these are some of the options we have, and I'll be focusing on some of the materials that has been developed at CSIR SCRC in this direction, materials and strategies. One thing is the geopolymer concrete, where we have been working for the last 20 years, and it's a type of concrete where we don't need the Portland cement at all. As all of you know, the production of Portland cement contributes massively to the carbon emissions. And this geopolymer concrete, we have done a lot of studies, and we have already built roads in our campus as far back as 2010 itself, and these roads are even now sustaining without major maintenance. And we also made geopolymer blocks, which has been used for building plasma room in our KV CLRI schools and 10 years back. And this technology has already been transferred to almost 4 industries so far. Another technology which has a large potential is the ferrocement technology. So this technology is not taking up mostly because it requires very highly skilled labor. But however, this is a very apt for prefabricated construction, precast construction. But the problem is that panels, when you make the panels, how to make the interlocking of the panels is a big issue. For that, SARC has developed a panel to back panel self-interlocking facility. And with this, we have developed several products, which has also been transferred to a number of industries. And another area which we have been working in the last 16 years is the textile reinforced technology. The technology to produce different textile or fabric reinforced simulated components for various structural and non-structural applications. So we have different applications like toilet units, color linings, tiles, crash barriers, stormwater drains, and even for strengthening. So these are some of the applications, and it has been also transferred to industry. So you can see the one toilet unit which has been implemented in the makeshift hospital by SCRC, and the crash barrier systems, even boundary wall systems and U drains. The major advantage is that its suction dimensions are very less compared to reinforced concrete, and it can be adapted for narrow spaces and non-corrosive. Since no reinforcement is involved, it is a non-corrosive material, and it can be customized for different applications and easy to transport and install. And we have already have 3 patents in this area, and it has been already transferred to 5 industries. The various applications has been transferred to 5 industries. And another aspect we have been working on how to make the construction faster and less time consuming. So for this, we have developed a header reinforcing bar anchor system, which is a innovative rebar end anchor technology. Such a technology is not available in India at present, and it has a tin bearing mechanism. And we have come out with 2 different anchor systems, which can help in avoiding the congestion of reinforcement and in ease of construction for different places. And it can be applied for different bar diameters ranging from 12 mm to 32 mm. And the end angles comes in 2 different shapes. And as we are saying that recycling of materials is another area which can help in reducing the emissions up to 70% emissions can be replaced. And if you see India, you can see that we have large amount of construction and demolition waste generated every year, millions of tons, about 150 millions of tons C&D waste is eating. But this waste is now not being used effectively. It is almost used for as a landfilling and other applications. But now we are working on how to use this C&D waste in construction as a structural and non-structural applications, as a replacement for fine aggregate, as well as for coarse aggregate, which will have a large impact in our construction industry, as well as in reducing carbon emissions, contributing to sustainability. And we are also developing codal recommendations and formulations of guidelines in this area. And also, when coming to next generation construction materials, we are working on engineered cementitious composites for the last 20 years almost. And we have a family of fiber reinforced cementitious composites designed using micromechanics approach. The major advantage is that there's a very high flexural capacity and can undergo large deformation. And it is also known as a bendable concrete. And using this technology, you can see the large deflections it can undergo without failure. And using this method, we have come out with different technologies like for application of existing pavements and bridges as link slabs in as an alternative expansion joints in bridges, which can avoid the lot of durability issues and maintenance issues and provide gliding comfort. And even ECC steel composite bridge ducts, which can have a very lightweight construction and faster construction with a very low initial construction cost. Another area which I've been working is the ultra high performance cement concrete, UHPC, which is a cementitious concrete material, which can have almost 5 times more strength, 5 to 6 times strength than your N30 grade concrete. However, its fracture capacity, that is, it has about 50 times higher fracture energy and almost half of the weight and volume of the normal reinforced concrete or pistorious concrete. And hence, it is very ideal as a precast material. And SCSC has now the capability to develop UHPC from strength varying from 140 to 220 MPa using local materials, and it has also used for strengthening of the existing members. And when it comes to 3D printing, we have been working in this area. The major problem in 3D printing is not printing itself, how to develop the material which is amenable for printing for different applications. This area we have been working extensively, and we have come out with different mixed design procedures, how to use for 3D printing for different applications. and it can it can solve different problems faced in construction industry like shortage of skilled labor, resource depletion, safety issues, and it can also lead to a savings of about 60% construction waste, labor cost, and production time. So this is one of the proof of concept that has been built at CRC in the recent times. And combining these two concepts, 3D printing and ultra-performance concrete, we have come out with the mixers which can even use for 3D printing of ultra-performance concrete mixers. And we can also build structures of complex geometry for this purpose. And some of the other green technologies and initiatives which have been working on is the innovative disaster resilient lightweight prefabricated building system using EPS panels. This has already been transferred to industries, and buildings have been also built using this technology in for mass housing schemes. And portable and lightweight transit structures, which is also known as fault alarm, which also has been transferred to industries. And bio-inspired functionally graded cementitious composite of a ballistic application, where we try to develop functionally graded cementitious concrete, which can withstand high impact loads, and high strength steel for structural application. Instead of the conventionally used Fi450 steel, we are going for high strength up to 90 or 720 steel strength, and functionally enhanced from concrete. And some of the new initiatives in this green area are strategies for development of low carbon built environments, and the also passive heating strategy for housing in cold regions, climate responsible design for energy efficiency, and even carbon capture concrete, which we hope that will go in a long way in developing sustainable infrastructure in the country. And we are also open for collaboration in all of these areas. Thank you.
Thank you, Dr. Next step. Digital technologies. We have Dr. Satyajit Sarpal, Chief Scientist of CSIR FTR, specialized in the map and design of structure and economy. His primary structure is by multi-chemical structures laboratory. CSIR SCRC scheme discuss on how modern digital tools and systems can revolutionize monitoring, including timely reduction of infrastructure issues to maintain safety and reliability. I welcome Dr. Satyajit to deliver his talk.
Respected chair, the speakers, and the participants. So here I am going to present on the infrastructure health monitoring and that with digital technologies. Because the first point comes is that why we need that health monitoring, or what are the real need for those type of that advanced technology. Because as we all know, the infrastructure growth and that the need for the infrastructure to adopt the requirement of the world population is extensive. And for that reason, the road, highways, buildings, and the lifeline structures are being built. The new structures also need to be seen and protected and preserved so that we can have the life extended. Also, it can be avoiding any sort of failure of this one. So this is the one of the global challenges for the infrastructure management that all the civil engineers are facing. But if you really see here this slide that shows that why do we really need as a monitoring? In the left side that we are showing some different pictures of different types of failure, because it has been seen as a building, bridges, even this wind turbine blades, even a pressure vessels, or in having the aircraft. It speaks a very unique thing is that even the engineering solution that which takes care of a very minute and very accurate type of the analysis, designing, modeling, all the things, in spite of that, all the advances, even the civil structure, industrial structure, and the power plant structures are seeing some sort of catastrophic failure. So this failure is coming due to a need that we are missing the in-between state of the stress or the in-between stage of the structure. Because of that type of thing is coming. So this is required to bring out that gap has to be merged. So how we can merge the gap is that generally for any sort of robust and the critical structures, we will be having a schedule-driven maintenance, inspection, and the strategy making. So from the schedule-driven maintenance strategy, if we do for the condition-based as needed maintenance. So here that we have underlined the word as needed means that we have to have a methodology or a technique or a technology by which we can understand that the need is coming. So that need is coming, that can be known by some sort of a monitoring or some sort of sensing. That is called having a structural health monitoring, and this is the paradigm shift from the regular schedule driven to the condition based as needed. As we said that when we need that as needed, that we need to get the response, and for the response that we should have some symptom. So the structural health monitoring, the analogy, it can be looking like a doctor. So a medical doctor, they see and monitor the patient's health. They'll be having some equipments and they'll be having some signals or the signatures or some sort of responses. And from that, the doctor is decoding that what could be the health of a person. In the similar way, the structural health monitoring engineer also, they'll be having a structure, they'll be having a specific type of the sensors, and they get the responses that has to be analyzed, and finally it has to be interpreted in a proper way. So the structural health monitoring, if you see, it is an ideal example of having an interdisciplinary field where a major role or the pivotal role plays by the structural engineers. Because the structural health monitoring needs the structure, signal processing, instrumentation, it's data transfer, finite element modeling all together. And that all the things together, when it comes into a one platform, that gives a unique advantage of the increased understanding of the structures. It actually can act as an early warning system. It can be used for giving a rational maintenance and the management strategies. Even it can be used for the structural health enhancement and also the life enhancement of the structures. Now at ACRC, the structural health monitoring and the life extension, the program and the thrust area, research thrust area is going on in a very deep and a very broad way for the last 2 decades or so. And here that we are working on a very futuristic and the cutting edge areas. So like nonlinear ultrasonic, acoustic emission, high frequency wave propagation using the Lamb wave technique, multimetric sensing, and the frequency fusion technique from a few hertz to a very big, having a megahertz level of frequencies and do the fusion. And also the one of the major bottleneck is that for the any country per se, that when the structural health monitoring is coming, that we need sensors, and the sensors will be generally prohibitively costly. So in India and here the ACRC also is playing a very important role to develop the indigenous sensors, and that will be cost effective in that sense. So here that we have developed a technique by which that when you are seeing a crack and when the crack is apparent, I think then many of the techniques are not required, and also sometimes it will be too late for a structure that you have found some sort of damage. So when a structure is coming having a micro crack or that you call having a breathing crack, that there is having a technology developed that by using the nonlinear vibration characteristic that we can not only identify the damage, even you can also assess that what is the degree of damage. The second thing is the ultrasonic tomography. There are many techniques are there, even the different industries also have developed indigenous coding and developing an algorithm by which you can localize the damage in the perfect way, and also you can see that how the prognostic behavior of the structure as the crack is getting propagated, it can be found by the technique, and where that has been used for the ultrasonic feature, basically the non-linear part. And when the corrosion starts, the corrosion makes the structure to be very weak, and it will be coming, the crack will be coming out, and that will be creating the habit failure. Now the challenge was there when the micro crack starts in the vicinity of the reinforcement due to the pressure created by the corrosion, whether that type of the initial stage of the thing that whether we will be able to capture. And it is so interesting to see that by using the nonlinear ultrasonic or by the acoustic emission, and that you have got the fusion of the data, because the acoustic emission and the ultrasonic, it shows that whenever, if you see in the graph, even that when the micro crack starts in the vicinity of the reinforcement where the actual crack on the structure is far away, so that type of the early warning system, it can be developed, and also it can be deployed to the nearby structures. And the digital image polarization and the acoustic, which is one is the active and the passive technique that can be used to see how the crack propagation is happening, because most of the massive concrete structure having a propagation studies and its characteristics will be giving you very so important information. So here is the thing is that if you have some of the structure that which are the thin wall structure, or the thin wall structure like a pipeline, or the sheaf wall structure that for which that we have used having a non-contact SHM technique by using the scaling laser vibrometer, by which you can pinpoint the exact damage, and seeing that we are using the lamb wave that which is having a velocity of 5 kilometer per second, so that you can be able to actually monitor it's a long range pipeline, even the intercontinental and this one pipeline also. And those techniques were actually developed in the laboratory. It was demonstrated in the scale. Then finally, that we have also deployed into the structural problems. So in that case, for example, we can tell that we have to use the acoustic emission technique for the integrity assessment of the dam structure. And for the railways, they're having the n number of bridges of different kinds and the different issues and the different challenges. But so if you see the ACRC is actually catering the need of almost the whole India that is being used. And for the cases that we have used for the different type of sensor based on the problem, based on the challenges, and based on the requirement. So that here the strain, acceleration, even the displacement, and sometimes the tilt, all the things that are measured, and it will be acquired and that will be processed. And as I was mentioning that the signal processing, interpretation, and the final recommendation will be very important. And because such a big and the important structures, if a solution comes in time and in a very preemptive way, that will actually save a lot of money for the country. And also it will be giving the passage for the passenger to having a no stoppage of the trains. Even for this so RDA so actually came for having if we go for so higher axle loads, whether the old bridges like a century old bridges also it can be still used, because it is a challenge, because the higher load in the train, it will be giving you a lot of the longitudinal forces. At ACRC, and the innovative scheme has been designed and it has been demonstrated, and so RDS has seen that how the real-time demonstration of the measurement of the longitudinal force, and also the successful mitigation of that force. So now that if you go for the higher loading, also the bridges may not feel that the effect of the higher load due to that, because of the invent of that being a shock transmission unit. And recently, that in the Pamban, that actually it is the bridge which is connecting the Indian mainland to the Rameswaram. And here, this is the first that vertical lift span. This is the India's first vertical lift span. So that has been installed, monitor, and that also that we have made the instrumentation scheme for the long-term monitoring, by which it is the world's one of the most corrosive environment, so that we can give the early warning to the structural degradation, if at all, if it is happening. So having said all the research and also the implementation demonstration, also so development of the technology that has been developed at ACRC is the development of the embedded smart sensor. So that has been used for the strain and acceleration measurement. And it has been also already the Indian patent has been filed. It is made of a cement and nanotubes, and it is giving a very promising result. And also that we are having the technology by which that we can develop some system by which the expansion joint, it can be completely eliminated in the bridges. I think that all of us are having an experience of having a very uncomfortable feeling that when the bus or the car goes over the bridges, so that it will be basically having a jointless that will come. And also at ACRC, the APG-based sensor has been developed, by which the railway flat monitoring also it can be done. And so this is the case that actually so ACRC, along with the other labs, they're developing indigenous sensor. So that the indigenous sensors are being so deployed in the villages, and so that how the results are coming so good. So these are the primary areas of focus. Actually, it has been taken as a long-term plan by which that the ACRC can be a point of contact for any sort of the structural health monitoring technology. in the implementation and the demonstration towards developing a cyber physical system and the digital tool. If you have any question and the CSIR.
What is or discuss this Lord speaks locally, keeps like it's an HRC. The next one on the is focus on strategies for designing that can withstand disruptive approaches to detect post disruption management. Welcome to Converge.
Thank you, madam. Good day to everybody present on this forum. I'm going to present disaster resilient infrastructure and post-disaster management. So internationally, disaster resilient infrastructure is being given a lot of emphasis. For example, Sustainable Development Goals 9, which says that build resilient infrastructure, and Sendai framework for disaster risk reduction. They also emphasize about substantially reduce disaster damage to infrastructure. Global Future Council on Infrastructure also have emphasis on disaster resilient infrastructure. And also Technology Vision 2035, which says that our entire infrastructure would have to be made disaster proof. So when we take the Indian context, India is prone to various other. I'm just focusing in this presentation cyclone, earthquakes, and man-made hazards. India is geographically almost 60% land is vulnerable to earthquakes, and 3/4 of population is residing in high seismic risk zones. Apart from this, Indian coast, 3/4 of Indian coast is susceptible to cyclones. So towards these hazards like cyclones, earthquakes, and man-made hazards, CSIR SARC has contributed with the help of state-of-the-art facilities like boundary layer internal facility, triaxial shake table facility, and impact testing machine and gas gun facility to address the man-made hazards. So towards this, first one is that multi-purpose cyclone shelter. A cyclone shelter is used in order to, especially in the developing nations, where the people living in the coastal regions vulnerable to cyclone, they get marooned during cyclones due to storm surge. So the cyclone shelters help in providing the shelter during these critical events. So SARC has developed a novel design for this multi-purpose cyclone shelter, and it has been adopted by Indian Red Cross Society with the help of German Red Cross Society. It has got a suitable aerodynamic shape so that they attract less wind loads, and provision of tilt and sloping ground to address the issues related to storm surge. And also they are designed to very high risk, very high cyclonic wind speeds, more than 65 meters per second, for which these are designed. And during 1999 super cyclone, these shelters not only withstood the that super cyclone, but also saved many thousands of people. And subsequently, these structures are further helping people provide shelter during various other cyclones. Another one in the cyclone specific and post disaster management is emergency retrieval system. Invariably during high wind events and cyclone events, transmission line towers do get damaged, and which will have consequence not just only the cost of the tower but also huge economic loss happen because of the power utilities not being functioned. So ERS helps in providing as a very quick solution, which is temporary in nature. Within 2 to 3 days, this system can be erected on the point where the power got damaged, and power supply can be restored in 2 to 3 days. So internationally, these ERS systems are available, but they are very costly. So indigenous system is developed, which is cost effective, less than 50% of the international cost. And this is transferred to 3 agencies, and patents are obtained in India and internationally. Further contributions are made to Indian standards, so that is part of Sendai framework, wherein which we should update the current course of practice. So this is one code where they address cost-effective design guidelines, how to make the buildings become more resistive to the cyclonic wind loads. This is another code which is providing pro forma how to collect the data of various types of housing and materials and construction practices, which will help in affecting the vulnerability, and also which will help in how to strengthen them on site. The other code is that parent code that corresponds to wind loads, for which we contributed in revising the basic wind speed map, and also an importance factor for cyclonic region, that is K4. With respect to seismic resilience, energy dissipation is very important. So the most of the times these structures where beam column joints are vulnerable to seismic energy related issues. So to absorb seismic energies, structural fuse elements are designed by SERC. So you can see schematic diagram here, where in which beam column joints, so these fuse elements are provided, and during seismic events they get damaged, and we can replace them after seismic. So these are very cost effective and no significant initial cost, and easy to replace also within short period. This is another thing with regard to seismic resilience. We fabricated building components using steel foam concrete composites, in which wall elements and slab elements are can be found made prefabricated, and it is made in such a way that they are lightweight and have the ductility, so that they attract less seismic loads. Hence, they are suitable for constructing G+3 buildings in Zone 5 seismic regions also. They don't need a shuttering, and they also provide thermal comfort. The other one, seismic resilience, is the open ground story building. They will be used for what is the car parking purpose, but they are highly vulnerable to earthquakes. So we have come out with retrofit methodologies, in which one of them is like providing shear walls in the existing buildings. So design guidelines were brought out after carrying out lot of lab level scale tests were done to assess the performance of these retrofit methodologies. Another retrofit methodology is that steel braces. These are also verified at lab level, and design guidelines were brought out. One software is also developed for the open domain, within which we can assess the existing building vulnerability to seismic, and what retrofit methodology can be adopted is provided in this software. Various other damping devices were developed, like elastoplastic device, viscoelastic device, base isolation device, magnetorheological device, state memory alloy based device, and MRE isolators. All these are for seismic resilience of not only buildings but also structures and structural components were developed by SCRC. With regard to man-made hazards, laced steel concrete composite system is developed, which has got enhanced glass resistance. These are very useful for bunkers, ammunition storage structures, and hardening shelters. So this technology is transferred. This is at lab level. Its performance was tested, and patents were obtained and transferred to one agency. And another one is that security booths, which are right now being adopted in a ad hoc manner. A systematic investigation carried out, and then come out with a solution which is more security booth, complying to NIG level 3 protection, and it comes with a lot of selling features like easy to replace in case of after multi-hit, and also this is technology transferred to two agencies. Thank you.
Thank you, Dr. Harikrishna. So we'll move on to the next talk by Dr. J.K. Goyal, Chief Scientist at CSIR Central Road Research Institute. He will address structural assessment of high-speed expressway corridor authorization, a critical step to ensure safety in large-scale transport infrastructure projects. I invite Dr. J.K. Goyal to make his presentation.
Yeah. Good evening, everyone. Can I share my presentation, or you will display my presentation?
So you can share your presentation.
Okay, let me see how it is to be done.
We can see your screen.
Now you can see my screen?
Yes, yes.
Okay. Now this presentation is, you can see my presentation?
Yes, sir. Can you please make it
full screen?
Yeah. Let me do it.
Sir, we are not able to see your presentation.
No, I'm sharing my screen. My screen is shared.
Dr. Goyal, we are able to see the presentation in full screen mode. Can you just shift it? We can see whether it works. Yeah, it's fine.
So it's fine. Okay.
So,
Yeah.
Madam, at Empri, we could not able to see that.
At headquarters, we are able to see his presentation. Thank you.
Now it has come.
Okay. 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 Let me start, please. My topic of discussion is today about the structural assessment of high-speed expressway corridors. They are basically expressway corridors being constructed by National Highway Authorities of India and being implemented all across the India. So basically, CRRI has been entrusted with carrying out structural safety audit of elevated structures primarily. Of course, there are tunnels also. So contents of my presentation would be about this background, the scope, and kind of the structures that have been audited, and observations, and then recommendations. So, the basic scope is basically to carry out the construction safety audit after mostly the completion of the structural works, but before opening. So the scope is given to us in Dwarka Expressway and Urban Extension Road, about 8 construction packages, and 2 construction packages in Delhi Dehradun Expressway in NCR, and 1 construction package is connecting DND with Jadpur NCR. That is the Sona Expressway Road. So audit has been undertaken by CRRI in a phased manner with regards to the progress achieved. But we made it sure that this structural assessment is done after substantial completion is achieved. An entire stretch is now open to the traffic, except the DND connections, and the CRI has received about 10 crores of sponsorship fees. This is basically the route map, project key diagram, wherein you can find these are the urban extension road basically. These are urban corridors which are functioning like expressways, and they are providing seamless connectivity to the external feeder expressways or for feeder national highways. The scope of audit remains the post-construction safety audit after construction of the work, which comprises of visual inspection and NDT on selective basis. It is not possible to carry out NDT in all these structures, so we selected the structures based on our visual observations, and we carried out this selective NDT, including the core testing and other testing in the laboratory, and review of technical documents, because a lot of technical documents are being collected during the inspection with regards to the third-party quality audit carried out by the different agencies. Then, according to our findings on visuals and NDT, we recommended the repairs and retrofitting work wherever it was required, although it was new construction, but there was a lot of shortcomings noticed, where we recommended some repairs and rehabilitation. But in this whole process, design review we have excluded because structures were already completed, so there was no sense made to review the design because the structures are already constructed. And basically, structures are the kind of structures that we have audited are basically elevated corridors. They are basically minimum 8 lanes and underground corridors in the form of shallow tunnels because there are multi-lane gate separators, railway overbridges, vehicular underpasses, major and minor bridges, subways, and these structures mostly comprise of PSC T-beam girders, box girders, composite deck slabs, and steel bow-string girders. So there are different variety of structure configuration that has been constructed along the highway. And the contractors used very innovative single pier design supporting dual carriageways because of the space constraints, because these alignment passes through the urban areas. So there were a lot of space constraints. So they used the innovative methods. They mostly provided the single pier, and on that pier, the 6-lane or 4-lane configuration has been adjusted. And there is a tunnel, shallow tunnel, which was constructed using the D-wall type technique. And of course, the highway has a lot of multi-grade crossings and overpasses. So this is the basic, these are the basic structures you can see. This is the figure of one package constructed by L&T. And this is a single pier. You can see the box girder with having these spines on both legs. And we adopted the various inspection tools like carrying out inspection through mechanical lifters, going up to the inspection point, even traveling inside the box girders. They are multi-cell box girders, so you have to travel in all the multiple cell all throughout the length of the bridge. We also deployed our indigenously developed mobile bridge inspection unit to carry out the visual inspection of outside concrete surface. You can see this is the unit that we had developed a couple of years back, and this unit has been extensively used to carry out the physical inspection of the structures. And we also deployed the various kind of the machinery available at our disposal through the contractors, where we have by use of which we have inspected the structures. You can see the view of tunnels. These are 4+4 4-lane tunnels in the Dwarka Expressway near the airport, and all these structures have been inspected by CRRI. And this is the bowstring girder that has been used in Dwarka Expressway. So it's a very good exposure to our team and trainees that we conduct the training course and we take them to the site. And we also provided training to the contractors, staff, NHI staff at the site, how to carry out the structural investigation. So our observation are basically on structural deficiency. We noticed a lot of cracks in the pier heads. Some of them are within the permissible limit, but some of them are not. In pier heads, girders, deck slabs, and abutments bearing pedestals. These were the cracks that we noticed during the inspection. There were a lot of honeycombing and voids in the selected locations because of the poor concreting. Elastomeric bearing basically has emerged as one of the weakest point in such projects where you find a lot of damages in the rubber material. So either their quality of the rubber is not proper, or their vulcanization is not the issue, or they are under design. Something has happened that requires number of replacement. And the anchorage bolt, pardon ma'am?
Please summarize. Can you please summarize?
Just give me 5 minutes, madam. Give me 10 minutes of my presentation time. And the leakage in construction joints and tunnels.
I think in another 1 or 2 minutes, please summarize.
Okay, yeah, another 2 minutes summarize. So these are the basically findings that has been observed on these structures. And there are a lot of maintenance issue because of the poor drainage and waterproofing. If they are not being taken care of, it will provide a lot of issue in the concrete distresses. So those have to be taken care of. Design concerns are also, of course, noted because they have not provided any future strengthening scheme using the external pre-stressing. So that could be one of the concern, and accordingly, that immediate actions have to be taken to repair cracks, honeycombing, and other the distress that we have noticed. And we have given the rehabilitation plan and the institutional mechanism that should be in place, that has been recommended to NHI. These are the standards and guidelines that we have referred to for the inspection and assessment. And our project provide basically representative snapshots of the construction quality. Deficiency that we have noticed has been intimated. And we have recommended that these things have to be done periodically. And let's see, the structure should behave properly. Thank you very much.
Okay, Dr. Goyal. Now we'll be in the last talk. Limited. He'll share valuable industry perspectives on building safe and sustainable infrastructure, bridging research and practice for real-world impact. Welcome, Shivaji.
Hi, good afternoon. Just give a second. I'm uploading the file. Is that everyone able to see my file?
Yeah, but in the full screen mode, please.
Yeah. Full screen mode, please. Is it okay now?
No, it's only in the presentation mode, not in the full screen mode.
Okay.
So you can move on. Probably you can move on.
Proud to say that we have been awarded the Corporate Green Campus Award, which is about 27 acres. With respect to the 2017 norms for the carbon neutrality by the government, L&T has taken a stand that we will first do the water neutrality by year 2035 and carbon neutrality by the year 2040. How we are going to achieve this? There are a lot of sub works targets are all given. One, we are focusing on increasing our energy conservation by 10% year on year. So this basically we are trying to use in terms of a lot of energy conservation materials, equipments, systems, processes using digital technologies. This is what probably we are trying to work on. Then at the same time, we also like to do a kind of energy efficiency. Then of course, emission control is one of the main thing. Like the first presenter when he presented, that's almost about 37% of the carbon emission is from the construction industry. We are concerned about it, and then we are working towards all these systems. Also, with respect to the safety point, because today's one of the topic is also on the safety aspect. So we are committed to Mission Zero Harm in Last Interbro. We are also proud to announce that in our campus we have the building which is TC4, which you are able to see on the screen. Laser. So we have that Technology Center 4, which is recently awarded the first India's first new net carbon building there. I'll have a small slide which I will explain you about later. Apart from that, within our campus, a lot of green initiatives we have taken in full swing. We have the environmental sensors both inside the office and outside to measure the oxygen, the well-being aspect of it. We have a smart lighting and power for energy conservation. We have hybrid solar and wind turbines in a small way, but still, yes, we have started the right step. Air quality index monitoring, then driving sustainability through digitalization. We have taken digitalization as one of the biggest initiative. Probably you must have read all in the papers there. Next slide. So we'll move to the next one. Basically, the topic is given based on SDG 9 and 11 principles. So in that, first, I would like, we have done in 3 stages. One is innovation in infrastructure, safety and monitoring, and then design development there. So first, let me take the innovation in infrastructure. So what we have done is, one is the lean construction, because that is what we thought one aspect of it. Then like a precast, we have done the toilet pods for the conclave, executive conclave in Delhi, CC 3 and 4, where what we have done is all the toilets, instead of doing a wet design, we have done a dry module, factory based, all completely produced, including the complete finishes, so that the carbon emission is reduced. We have used the materials which are all green certified. So this is what you are seeing is the simple kind of a quick image of what it is being done there. And then can you minimize this? Yeah, it will. So then we have got what is called as the transit part you can see, and then the site commissioning also it is being done. This is successfully done more than about 306 units of toilet. Yes, initially it was very difficult to convince the government and get it, but we are already there, and then we are expanding this process in our other projects too. Then the second one is in the 3D printing aspects, where L&T has taken a very large scale, where we started experimenting from 2019 and 20. First building official thing we have done is the post office building in Bangalore. It had the appreciation from the Prime Minister in a special mention about it. Then we have extended this for our border roads organization in Chandigarh, where we have done more than 1 lakh of square feet using 3D printing, ground plus 2 structures. And we are also discussing with institutes to see that how we can do it for ground plus 7, so that the lot of mass housing can be taken in a large volume. We also printed a lot of villas for one of our private client in Bangalore. So this is another way of implementing innovation in action.
So you can
Next
take
one.
another 5.
Yeah, I'll quickly finish it. Yes. The net zero is the other one where we have achieved about 30% of 30% reduction in our embodied carbon. And we already received certificates for design with respect to the water, waste, as well as the net zero energy, and finally the net zero carbon. Right side, what you're seeing is all the major airports where we have done green building design to suit the platinum part. And almost we have done the energy conservation almost about 20 to 25%, depending on the type of airport with respect to the base thing. Next one, please. Coming on to the sustainable design and construction aspects. This is one of our project in Mumbai, Sitco project, where we have taken the complete support in terms of the power requirements from green power. We have taken, we have avoided all our fossil power, and we have able to save about 1,270 tons of carbon emissions is reduced. The same thing we are doing in other big projects in a large way. Mumbai and Gujarat we are doing in a big way. Tamil Nadu also we are doing, but here we don't have that green power, but we have exchange of power. We are the credits we are doing it. Some of the sustainable construction in terms of the materials, one is that hybrid solar and wind turbines, smart AHUs, energy efficient chiller, because normally in any of the buildings design, 60% of the power is consumed by the air conditioning and another 20 by the electrical, balance 20 by the other ELV systems. So we are there everywhere in terms of optimizing energy, going for the latest material specifications, the best of equipments in terms of efficiency, and I think thereby we are reducing the carbon footprint and saving the energy. And we all get all these products. What on the right side you are seeing the EPD. They're all the green certified product is what we use in project, depending. And then we educate our client also in terms of going for the green energy. Next one, please. The other aspect is the moving on to the green energy on the right side. Whatever you're seeing, many of our projects in building, we are securing the clean energy. We are trying to reduce or eliminate the power of consumption of the fossil fuels, namely the diesel and petrol. We are moving in the right direction as set by our L&T's target of reaching 2035. Yeah, next one, please. Coming on to the safety and monitoring of infrastructure, one of the biggest scope for us is to avoid accidents. So zero harm is our like our Bible. We follow that in full essence. We use a lot of the technology for the implementing the safety. We have got the beautiful and one of its kind of L&T's pride in terms of having the safety platform, digital platform, where we review, monitor, all the documentations are done through the digital. The virtual reality, the safety training is given to all the workmen. They undergo a virtual thing. We do the simulation thing also. And then we try to improve our safety records on that. The next aspect is monitoring aspect. We have a lot of digital tools, IoT driven. We start monitoring starting from my small equipment to the major equipments. We implement at every project site. Digital implementation is highest order in any of the L&T project sites. If you really see, we have one network where we have the complete insights, water, energy, complete metering, and then we are monitoring in terms of optimization of the consumption. Similarly, the HSD consumption using for the heavy equipments, because we use large P&M plant and machinery items. We are very focused. We have a target to achieve, and we go all out to achieve these results. So in nutshell, if you really see, we are totally into green. We have taken a lot of initiatives in terms of green building certifications. We have more than about, in now my division itself, more than about 30 people who are green build certified. We educate our customer. Our own L&T buildings, we are setting a benchmark in reaching the net zero concepts. All our new buildings, which are all there, we are imposing those conditions so that we can achieve by 2035 our target of carbon neutral, energy neutral. Yeah. Thanks for the opportunity given, though it's such a short time. I hope I could able to communicate or convey the importance of green and the practices we adopt in L&T. Thanks for your attention. You can reach me at my mail and our website. Thank you all.
Thank you, Shri Shivaji. So, consolidating the input from various speakers, materials form the basic building block. Material structure integrated approach is needed to be adopted for better and safer infrastructure. Number of technologies were showcased in the talk. Second one, maintenance is an important issue to be addressed to prevent catastrophic failure, and it saves resources. And also, monitoring is an essential step. In case of disaster, including those due to man-made, we need to have a holistic approach addressing various vulnerabilities. As there is trust in the area of high-speed expressway corridors, safety issues and solutions to address them needs to be developed, as highlighted by the speaker. Research to reality is possible once industrial research or working or co-working, so that solutions are implementable, ensuring safe infrastructure for safer tomorrow. To summarize, shaping infrastructure for safer tomorrow, from research to reality, the 3M materials, monitoring and mitigation is essential as seen from the different talks. Thank you. We'll move on to the next theme. Thank you.
Stop
If there is
sharing.
any question, pose it on the chat box, we can answer it.
Director sir को बोलो. Yeah, yeah, please. Yes, sir. Please, you have to, sir, chair the session. I'm sharing my screen. Is my screen visible? Is my screen visible? No, sir. It will take. Yes, it is.
Yeah, it is visible.
Yes, sir. It is visible.
Yes, it is visible.
Yeah. So, first of all, good afternoon, everyone, and good morning, good evening, because people are attending across the globe this session. And welcome to all the dignitaries who are present, especially from the industry and also my colleagues from CSIR laboratories. So I'll just give the brief of this session, that is climate resilient buildings and technologies. So we all know, one second. Yeah, we all know that global warming is ongoing burning issue, and there is a climate change due to which there is an increased risk to buildings and reduced lifetime of the buildings, and also indoor environment is also deteriorating, and there is a lot of emissions which we need to control. So active techniques are available, but still they are energy intensive. So it is better to follow the passive strategies like solar control, thermal comfort, thermal control, thermal zoning. All such techniques we need to adopt and follow. So natural ventilation, indirect evaporative cooling, night ventilation for hot and humid climate and hot and dry climate, and finally achieving to net zero emission. So all these things will be discussed in detail in today's deliberations. And then next one is climate resilient buildings. As a part of CSIR mission mode project, we have worked on various climatic zones. So what kind of buildings will be more suitable? So like cold climate in Leh, Ladakh area. So the model climate resilient building has already been completed, and the details of this will be discussed by the concerned principal investigator. And then another climatic zone, that is composite climatic zone, which is Roorkee. So there also we have constructed, and performance of the building is very good. And in almost all these buildings, delta variation, that is the outdoor and indoor climate is coming to be around temperature around 8 degrees. So various technologies will be discussed by concerned principal investigators. And then coming to warm and humid climate, which is Chennai, which CSIR, SCRC has taken up the project. This building is constructed in their own premises. And then one building which is almost near ready, that is hot and dry weather conditions in Pilani. So this is using EPS panels and agro-industrial waste. So this is reducing reduction in the solar heat gain is taking place in this one. So far we could able to demonstrate CRB buildings in 4 climatic zones. And then the other contributions from CSIR, CBRI towards this topic, that is climate resilient buildings. So we have several guidelines, and this PAHEL, which is a document released by Honorable Prime Minister, wherein many around 150 designs catering to 15 states. And the second phase of this PAHEL, that is digitalization of the building technologies, has been going on right now. And then in addition to that, climate zoning for rural housing in India, that one. And then ventilation for residential and office buildings. So many documents have been released by CBRI, and CBRI has contributed for National Building Code, which is now new code is coming up very soon. For that also, immense contribution has been taken place. So with this overview, I'll hand over to Professor S.K. Singh ji to continue the sessions.
Very good afternoon to all. So you know that next session will be by Dr. Ajay Chaurasia on.
There is an echo, Professor
Please,
S.K. Singh.
Dr. Ajay Chaurasia. Yes, sir. Please.
Is my slides visible?
Okay.
Huh?
Yes.
Yeah. Yes, visible.
Yeah, thank you. So
Yes,
screen again. Okay. So greetings to all the distinguished delegates, friends, respected colleagues from across the border, and respected colleagues from CSIR, CBRI, ladies and gentlemen. So it is my privilege and my pride duty to present the efforts made by CSIR CBRI on climate resilient buildings for Indian Himalayan region. So when you have you talked about Indian Himalayan region, which basically having a length of around 2,500 kilometers, having an average width ranging from 200 to 400 kilometers, comprising 13 states of India and 4 neighboring countries. Interestingly, this particular region is having varying heights in above MSL, which has been classified under modern, moderate, high, and extremely high based on its elevation. So we are very much concerned about the high and extremely high regions where the habitat is likely to come. Apart from that, the challenge is that this particular region is having extreme climatic extreme climate in terms of temperature, maybe up to -20 to -40 sometimes, and the relative humidity is around 70%. No moisture in the air. Thereafter, the wind speed is very high, reduced oxygen and difficult terrain. But importantly, from geographical or geophysical point of view, it is a very fragile young mountain, and that's why the natural disasters, particularly the earthquake, landslide, and nowadays because of climate change, there is a lot of cases about GLOF. So that those things are putting that particular region under danger. So there is a substantial need that to look into from material point of view as well as from the disaster resiliency point of view. When you talk about earthquake risk in this particular region, so that can be further classified as per our recently revised code under normal buildings, for critical buildings, and for important buildings based on their return periods. So this particular region generally varies a PGA value from 0.5 G to 0.75 G. As against the wind speed, when you talk about, it is around 55 meters per second and plus at some time window. So keeping in view this all kinds of disasters, there is a substantial need to look into how my habitat, which whatever is coming, is safe, sustainable, economical, and robust enough to face these challenges. So for that purpose, under this program, we are focusing on sustainability aspect, sustainable development, which makes use of locally available construction materials, skills, water conservation, and in that case, we are trying to respect the traditional constructions as against the conventional and modern constructions also, how we can integrate. While integrating, we need to embed the energy efficiency in this particular building typologies, and that is from durability point of view and incorporating all kinds of passive strategies. Apart from that, important thing is resiliency. So while doing designing, not only it is designing of the buildings or structures in particular, it will be focused not only from simple structural disaster point of view, but climate resilience design is also in focus. So robust design is needed for such regions. So before going into detail, let us have a look on present construction practices being adopted in olden days and in past, in present. So in past, in different regions, there were technologies or building typologies which are tak or katkuni, dhaji diwari or trombe walls were adopted. Ikra walls and other things are also there, but these are the prominently adopted construction technologies, wherein basically the entire walling is made up of a wooden, which has been segmented into small pieces, and that is infilled by means of a locally available material, but predominantly stones in mud mortar or sometimes lime mortar. Basically, they are not only bringing the robustness from disaster point of view, but also from bringing value addition from climate resiliency point of view. In contrast, the modern constructions which are happening, which has been noticed by us, which is inappropriate from climate resiliency point of view, though they are complying to the disaster resiliency point of view, and they are consuming extremely high amount of energy in while heating and providing discomfort to the occupants. So that's why there is a need to look into this aspect. Apart from that, we have to learn from the past, from ancient people as well, the construction features and their planning aspects. They used, in general, they have an entrance on the eastern side, and all the habitable or maximum used utilities in the building or in the house are pointing towards southern side, whereas the least important or least usable services are located on northern side. In addition to that, while the planning, it is very important that we should focus on small window size for minimizing the heat losses, as well as increasing the larger window size on the south side, so that you will get large amount of it. And in addition to that, you have to integrate this with the material which will store the amount of energy and which will minimize the energy requirement for heating purpose, or it will not provide a discomfort to the occupant. At the same time, you need to focus on less volume to reduce heat losses. So in general, the planning or principles of designs in such region should focus on orientation. Normally, the good practice to provide the orientation is longer direction buildings facing towards north and south, whereas minimizing the area to volume ratio, then the smaller window to on the northern side and larger windows on the southern side, cavity wall constructions, and integrating this with different kind of insulating materials, then double wall systems, double glazing systems, and greenhouse effects. These are the different principles which need to be focused while designing buildings in this extreme climatic conditions. Keeping in view this, after putting a lot of efforts at CSIR, CBRI by different scientists working in different disciplines, we have come out with the real life demonstration of a building, incorporating all the aspects. So I'm focusing on the building which has been constructed at Leh, extreme climate conditions, which basically focuses on planning aspects, making use of locally available materials, particularly mud and stone concrete blocks. Again, these materials were envisaged and designed and evolved at CSIR CBRI. In addition to that, hybriding the envelope system, passive solar heating spaces, and from disaster point of view, basically we understand that the masonry buildings are quite vulnerable from seismic point of view, and this is a highly seismic region. So earthquake resistance have also been kept in focus. Apart from that, water resistance and other aspects. So this is the full view of the building, which was constructed within a span of around 45 days. So for which the in-depth planning have been gone into, and these are the various stages of construction during these 45 days. So for that purpose, we had a handholding with ITBP, that is the Indo-Tibetan Border Police. So that is with that we have constructed this particular building. So these are the various stages of constructions by involving local artisan and local materials. So this is how the construction of building has been done. But this building has not simply been constructed, but has been extensively instrumented by at various locations to evaluate the efficacy of materials in terms of material performance, in terms of their directions, walling units, and roofing. And the data has been recorded, and it was noticed that very high efficient performance of the building has been observed if we honor this sustainable aspect as well. So delta T has been observed during the extreme climatic condition to the tune of around 10 to 12 degrees, and which is providing quite a good thermal comfort. In addition to that, to reduce the energy consumption in terms of heating of water or other purposes, so solar water heaters have also been embedded in this particular building, so that a full-fledged solution is given to the occupant. So this is what the attempt to integrate the traditional constructions with the modern technologies and instrumentation. So that is a very good platform and improvement in the database and Indian standard at international globe level. Now let us have a focus from traditional construction to the modern construction technologies. So nowadays 3D concrete printed buildings are widely talked in, but we have constructed full scale rural house building in CBRI, but this is not a simply 3D printed construction, but we have tried to embed the seismic resiliency into it by constructing the walls in a hollow, the way you can see in this particular slides. In addition to that, these cavity walls features what we have incorporated. We are evaluating this construction by infilling various insulating materials, namely benchmark is cavity wall, then bentonite, sand, thatch roof, PU, glass wool, rock wool, rice husk, and EPS. So likewise, we have constructed 9 3D printed buildings, which are being deployed with various insulating material, and it is instrumented and monitored, and within certain time we will get a good data, and that will demonstrate how we can camouflage the traditional construction, modern constructions, and comply the climate resiliency in our ecosystem in Himalayan region. In addition to that, not only we should depend on the single technology, we have already evaluated precast RC hollow core walls. So in this, basically two thin RC walls around 65 thickness is constructed. It is adequately reinforced, and central portion is hollow. And this has been evolved jointly by CSIR, CBRI, and BG Shirke Construction Technology Private Limited, a leading firm in precast. And it was not only it was evaluated the design, it was evaluated for the walls as well as the connection between the precast hollow columns and beam under seismic loading. So in this, we can fill this cavity by means of various insulating materials the data what we will generate from the previous studies, and that's how we can, if even if we want to go high rise in such region, this precast technologies can be implemented, which will provide the all kind of robustness, not only from disaster but also from climate resiliency point of view. In summary, I would like to mention that the Indian Himalayan region is really it is basically it is a harsh reality, strategically very important aspect, and various R&Ds have been gone into, and CBRI has legacy in providing various solutions to the whatever issues which are being faced by the people living in Indian Himalayan region, and identify the gap and fill those gaps by various researches, as I have discussed a very few of them. And that's how we want to align ourselves, and we have tightened our belt to meet the national commitment of net zero 2070 by scaling, and at the same time the scaling and repeatability and other aspects can also be embedded. Thus we want to integrate traditional construction with conventional and modern technologies, and meet out the sustainable development, energy efficiency and resilience, everything at once go very shortly, and provide the comfortable solutions to the occupants in the region. So thank you so much for your kind attention and patience here. Thank you.
Thank you, Dr. Ajay, for making up presentations nicely. And next lecture is mine, particularly on sustainable materials and building constructions issues and challenges. I'm not going into the details, but our previous speakers has already been spoken on that. Definitely the traditional materials are being emitting a lot of greenhouse gases. If you look into the cement, is being 1 ton of cement is emitting about 0.9 to 1 ton of carbon dioxide into the atmosphere. Similarly, that steel, if you take 1 ton of steels, are producing about 2.5 tons of carbon dioxides into the atmosphere. So not only that, natural materials is that traditional materials are producing greenhouse gases and energy intensive, but also they are generating huge quantity of waste material, and that is to be required to be used. If you look into the C&D waste, which is being, if global, it is 2.1 billion ton. In India, it is more than 350 million tons of C&D waste every year, and it is increasing day by day due to infrastructure advancement. Similarly, that if look into the fly ash, right now it is been about 267 million tons, and being continuously increasing. Similarly, that slags, lime sludge, fluorogypsum, phosphogypsum, several waste are being generating, and that's to be used effectively and efficiently into the building constructions. And if you look into the challenges, definitely we have lack of standards, sustainable materials, and that consensus. If you look into the consensus, that is how we have to use those waste. And CSIR is continuously providing inputs, are doing research and development in these areas, and providing sustainable solutions how we can utilize those material into the construction sector. And we are working to come out with these challenges. So that we have been continuously working how we should work on C&D waste and different processing, that green processing and different type of products we have developed. Not we have worked extensively on recycled fine aggregate and coarse aggregate, as well as that lightweight materials, pervious concrete, etc., and been utilizing into the different building products. And we have transferred those technologies to the different industries, and they are utilizing. And our technologies for the bricks, blocks, road constructions, and a very good quality coarse aggregate as well as fine aggregates has been made. Similarly, if you look into that cement, that in India itself capacity is more than 650 million tons, and we are producing about 450 million tons of cement every year. So we have continuously working towards cement free binders, particularly on geopolymer binder or alkali activated binders. Not only that, we have carried out extensive research at CBRI Roorkee, and demonstrated it at CBRI and also on different part with the help of NTPC, and whole the technologies for making these geopolymer binders and concrete we have transferred to the NTPC and National Thermal Power Corporation, utilizing in different their projects, and we are providing them technical guidance and input for the different projects. If you look into that one sector which is been steel slag, and that has been produced huge quantity, particularly that right now we have more than 147 million tons of steel, and by targeted 2030 we are being going to increase that steel production by 300 million tons. And right now we have a slag about 50 million tons, and it is going to increase tremendously. And different type of slags has been utilized at CBRI. We have worked extensively on processing, and we have utilized into the binders by activating those steel slags, and also we have utilized the electric arc furnace slag and LD slag to making tripods, and which has been placed at Dolvi near Mumbai. And also our partners Center Road Research Institute has worked utilizing those slags, are particularly in the road sector. And by this we are achieving not only reducing the waste material from the landfill sites, and we are utilizing in a sustainable materials into the construction sector. So by this way we have been effectively reducing the waste material from the site. Similarly, that at CSIR we have worked at CBRI on all the waste of paper industries, particularly pulp sludge, ETP sludge, lime sludge, boiler ash, and ETP sludge. And that we have converted into building bricks as well as blocks, and that we have been made putty, that is eco-friendly putty. And both the technologies has been transferred to one famous industries, Mrs. Ruchira Paper Industries, and they have already put their plant at Kalam near Himachal, in the state of Himachal. And also we have synthesized those lime sludge into gypsum, and we are been initiating for technology transfer to some cement industries. Also, if you look into that, we have worked on precast lightweight composite materials, where we have utilized, all the type of waste material along with the cement, and where we have used that EPS as well as puff, LECA, and polypropylene fiber, and making those panels for insulating panels as well as the partitions panel and load bearing wall panels we have made at CSIR CBRI Roorkee, and that has been also in advanced stage for the technology transfers. Similarly, CSIR CBRI has worked extensively on quota stone slurry, and not only that, utilized those slurry into making building products. Also, we have utilized into the cementitious binder as additives or performance enhancers, and that has performed very well. These technologies has already been transferred to more than 4 industry partner, and further works are going on to make more and more industry partner. Another work which has been carried out at CBRI, that was wood without tree, where rice husk along with the virgin polypropylene fibers, about 20%, we have made a granule, and extrusions has been taken. Different wood type of materials has been prepared, and those would like appearances rather than very good, meet all the requirements of National Building Code 2016. It is termite resistant, very carpenter friendly, and we can have a replaces to the natural wood. Also, we have done sequestrations of that different type of minerals. It is being CND waste, slag, as well as fly ash and other biomass, and effectively we have converted into lightweight aggregates and enhancing the properties. And we are being in touch with the industry like JSW and others to be converted into the building products. So continuously CSIR CBRI is working in these area. And I would like to say that continuous work on this, particularly on waste utilizations, CBRI is working, and we are continuously providing the services or newer products to the industry, and towards making sustainable constructions. And not only this, we have developed several technologies under banner of CSIR and been transferring to the different industries. Further different newer areas we are working, and all potential applications of waste materials, converting them into resource material in the construction sector is going on. Thank you very much. Next speaker, I would like to request Dr. Mudgal. He can share his
Yes,
things.
sir.
And
Yes, sir.
yeah, please. Yes.
Good afternoon. I'm sharing my presentation.
Please. Yeah, it is visible. Yeah, please.
Yes, sir. Is it visible, sir?
Yeah, it is visible. Yeah, go ahead.
Sir, first of all, good afternoon to one and all respected directors, CBRI, Roorkee, and Director CRC Chennai, and my director, Dr. Thallad Bhaskar from CSIR EMPRI, and all honorable members from CSIR. Thank you for giving this opportunity to join as and giving my talk. So I am giving my talk on advanced geopolymeric concrete for climate resilient infrastructure. I am Dr. Manish Mudgal, Chief Scientist at CSIR EMPRI Bhopal. Need of climate resilient infrastructure is infrastructure around the world is increasingly vulnerably to climate resilient hazards like flood, heat waves, storm, rising sea level. Therefore, we are in growing need of making materials which can withstand the extreme climates. So, limitation of traditional concrete, that is ordinary Portland cement concrete, is energy intensive and it emits around 1 ton of carbon dioxide per ton of cement production. Whereas the geopolymer concrete is a low carbon, high performance alternative to ordinary Portland cement concrete using industrial byproducts like fly ash. It is being made by fly ash, GGBS, rice husk, and activating this particular waste materials by alkaline solution. So geopolymer concrete is a sustainable, resilient and environment friendly alternative as compared to OPC based concrete. And the basically concrete contains 20 to 30% binder, 50 to 60% coarse aggregate, and 20 to 30% fine aggregate. This is the background that cement produces around one ton, means around 0.9 tons of CO2 per ton of cement production. It is highly energy intensive process. Around 1450 degrees centigrade is required to make the clinkers, and cement production results in 8% of world CO2. So this is a highly energy embodied energy material, as well as highly highly polluting process. So we have developed this geopolymer utilizing fly ash. So availability of fly ash in India is around 232 million tons per annum. It's a aluminosilicate material and combination of glassy and crystalline phases in having pozzolanic characteristics. The geopolymer is derived, means the name came from Professor David David in 1978. He has coined this name geopolymer, and he has given that geopolymers are synthetic alkaline aluminosilicate material produced by reaction of solid aluminosilicate with a highly concentrated aqueous alkali hydroxide and silicate solution. When we compare this Portland cement with the geopolymer, this is a Portland cement process is highly energy incentive, and then geopolymeric process we need only 35 to 80 degrees centigrade. And other advantage of geopolymer is it doesn't require water curing. So, and it is 83% less carbon dioxide emitting concrete. So only 0.17 tons of carbon dioxide is being emitted by 1 ton of geopolymeric binder. So this particular, both the processes, the comparative, the geopolymer binder and concrete is eco-friendly concrete. Next, when we compare the engineering properties of this geopolymer concrete, so geopolymer concrete is resistant to segregation and bleeding. It doesn't require water curing. It is high thermal resistant. We have worked up to 700 degrees centigrade. It retains its strength up to 700 degrees centigrade, whereas cement concrete loses its strength at around 550 degrees centigrade. It is resistant to sulfate and acid. It is having low shrinkage, low thermal expansion, low creep, and durability is excellent. We have demonstrated this geopolymeric concrete road in our CSIR MPRE premises in 2014 of 34-meter length and 3.75-meter width with 150 mm PQGC. We have used around 8 tons of fly ash and developed this concrete with a compressive strength 35 MPa and flexural strength 4 MPa. In first experimentation, we could reach slump of 30 to 40 mm slump for workability, and it is having low workability. And then we have modified and we have the process, and in 2017 we have demonstrated this particular geopolymeric concrete in All India Institute of Medical Sciences, AIMS Bhopal. And in this particular process we could reach up to 200 mm slump, and we have got very good finish, and we have got 4 patent granted, US patent granted on this particular technology. And with this particular geopolymer concrete, we have already also developed high strength paving blocks for infrastructure. In the line of this, we have also developed one small structure, reinforced geopolymeric concrete structure in the premises of MPRE Bhopal. And this structure is here since last 15 years, and it is giving afterwards we have gone for non-destructive testing methods, and we got very good strength of this structure. This durability is very much assured. We have also developed red mud fly ash based geopolymeric paving blocks We have developed around 5,000 paving blocks at MP Bhopal and demonstrated in the premises. And the second picture is of present status of these blocks. It is it is giving very good durability, and it's the unique property of this particular block is it is eco-friendly process and anti-skid properties. So there is no algal growth on these particular blocks. So it is having this unique property. Now I'll tell you the high-end application of geopolymeric concrete. We have developed red mud based synthetic aggregate. Red mud is aluminum industry waste. We have developed red mud based synthetic aggregate of specific gravity 4.12. It's a high density aggregates, and using these aggregates we have developed a geopolymeric concrete, heavy density concrete, and which has been tested, which has tested at for gamma ray X-ray and gamma ray attenuation test at BARC Mumbai, and we got very good results of around 10 to 12% higher attenuation than hematite ore based cement concrete. So this is a unique feature of this particular concrete. It is having high density and it is capable of attenuating gamma rays, and the developed radiation shielding concrete having gamma rays properties can have application for nuclear power plants, bunkers for strategic sector, and medical diagnostic sectors. Salient feature of this advanced geopolymeric concrete for climate resilient infrastructure is advantage for climate resilience, resistant to sulfate attack, corrosion and chemical degradation, better resistant to water and chloride ion ingress, perform well in fire prone and high temperature environment, useful for rapid construction in disaster prone areas, and mitigate climate change by reducing greenhouse gases. So thank you from my side. Thank you for giving this opportunity.
Thank you, Dr. Manish, for making a presentation. Next speaker is Dr. V. Ramachandra. He's a president of Indian Concrete Institute, and he's going to speak on decarbonizations of construction industry, and he will focus on strategies and technologies. So I'd like to request Dr. V. Ramachandra to kindly share his presentation, please. Very good afternoon, sir.
Very good afternoon, and I thank you all for giving this presentation. Please let me know whether the presentation
it is a visible, sir. It is a visible. Make it full.
Yeah. I think now it is done. Very good afternoon and good evening, ladies and gentlemen. This is on this presentation in on the construction industry because India has committed to net zero emissions for concrete by 2050 and for cement by 2070. What are the strategies that industry is trying to follow? Initially, even I thought that 2050 is far away and 2070 is still far away. Therefore, at least people of my generation need not worry about it. But then every year there are targets to be fulfilled. Therefore, it is incumbent upon everybody to follow the norms. We talk about sustainability, net zero, etc. And therefore there is a sense of urgency in this. Why this sense of urgency? It is because of the dates that India has committed for cement and concrete. Now, for any industry, now investors have started questioning. World Bank and Indian banks, whether it is in the government sector or in the private sector, they have started asking these questions to the industry. What is your greenhouse gas emission? And what is the carbon footprint that you already have? And what are the steps you are taking to reduce it? And what are your timelines? And getting funds or loans from the banks is quite important for the industry. Therefore, every industry has to look into this and follow this. And we also have the threat of carbon border adjustment mechanism. it is becoming a reality on many construction materials, including aluminum, cement, and steel. Therefore, there is now greater focus on carbon capture, utilization, and storage, carbon dioxide sink, and recarbonization. Now, if you take concrete, in concrete, cement would be only about 12%. Cement would be 12%, remaining 88% is aggregates and water and so on. But though cement is only 12%, but as far as its carbon dioxide impact is concerned, this 12% cement contributes to about 95% of carbon dioxide in concrete. Therefore, this is a serious issue that we need to take up. Now, what are the different ways of reducing carbon footprint in concrete? One is to use cement with low clinker factor. Second is to optimize cement content in concrete. This is quite important because in India, we are known to produce most inefficient concrete, particularly in the informal sector. In projects, it is different, but in informal sector, which consumes about 65 to 70% cement, this is a very inefficient way of making it. And the third is, of course, to optimize the concrete usage through efficient design of the structure. And fourth and the last is the use of recycled aggregates and fine aggregates. Now, the first one very quickly, these are the steps that cement industry has taken, their part of contribution as far as decarbonization is concerned. One is cement substitution or reduction. Nowadays, we all know that earlier, about 25 years back, OPC production was about 80% and about 22% was blended cement production. Now it has reversed. Close to 80% is the production of blended cements by cement industry and hardly 20% is the OPC. And cement industry is using alternate fuel and raw materials, pet coke and municipal solid waste and so on. And improving the energy efficiency, particularly this through renewable energy, various sources of renewable energy, and particularly this waste heat recovery is a major step taken by the cement industry. Now, we all know that to make clinker, the ingredients have to be heated to up to about 1450 degrees centigrade, and whatever, when it is cooled to the room temperature, that heat is absorbed, that is the waste heat that is absorbed, and that is reused to heat the next batch of clinker up to about 700, 750 degrees. We can use this waste heat. Therefore, to that extent, energy consumption is reduced. And there are newer technologies, novel cements, and as I was telling you, carbon capture and storage and utilization. Now, when very simple and a quick example, what would be the carbon dioxide emission in a typical M30 concrete? Just for comparison, if you use only OPC, no SCM, that is the second column, you can see out of the total cementitious material of 320 is OPC, no other material is used. The carbon dioxide emission would be about 292 kg per meter cube. Therefore, if you replace it by 30% of fly ash, 292 will become 228. That means 22% reduction. And if we replace it 50%, either by fly ash or by JGBS and fly ash combination, as in the case of composite cement, it would reduce to somewhere around 160, which means there is a reduction of 45% carbon dioxide emission in the M30 concrete. Therefore, in the coming days, even our colleges and research centers, they would study not just on the properties of concrete as far as strength is concerned, workability is concerned, durability is concerned. Now the added dimension is sustainability and the carbon footprint. This calculation also would get into our design. The second, just before going to the second one, I would like to mention that Bureau of Indian Standards has brought out low clinker cements. One is the composite cement with 45% clinker, and the other is LC3, limestone calcined clay cement, with 50% clinker. Therefore, to that extent, clinker reduction happens through these newer varieties of cements. Now, going to the second possibility, optimizing cement content in concrete. In concrete technology, we are all taught in our colleges that if we have to increase the strength, there are two parameters. One is the cement content, another is the water cement ratio. Therefore, if we have to get about 25 to 30 MPa of concrete, maybe the first column you would see that cement content roughly it is in the range of 350 kg per meter cube, and water cement is in ratio is in the range of 0.4 to 0.6. If we have to get higher strength of concrete, that is, let us say 50 to 60 MPa, all that we need to do is increase the cement content 450 kg per cubic meter, plus use silica fume, etc. Reduce the water cement ratio, you would get that. Further, if you go further and further higher as far as concrete strength is concerned, your cement content would go to 650 to 700 kg per meter cube, silica fume plus others would add, and the water cement ratio would be 0.2 or even less than 0.2. Therefore, we can produce even ultra high performance concrete of the order of 150 MPa to 200 MPa. Now, one thing that we should keep in mind is this approach, does it take care of the space filling character of hydrates is a question. Therefore, this is not a simple way of concrete mix design going ahead. We need to consider the compaction of the ingredients and the gel properties and rheology of concrete. All these we need to consider in order to make an efficient concrete mix design, not just cement content and water cement ratio. Now, coming to the third parameter, use of recycled coarse aggregates and fine aggregates. There are several ways of doing this. In the earlier slides, Dr. S.K. Singh and Dr. Chaurasi have talked about various other options for this. I'll just showcase one single example of using this. Bottom ash is available in our thermal plants in a very big way. And as we know, a 1000 megawatt power station would consume about 12,000 tons of coal per day. It generates 4,200 tons of ash per day, out of which 20%, that is around 800 to 850 tons, is the bottom ash that is produced. Now, whether we like it or not, 67 to 69% of electricity is generated in India from coal-based plants, and therefore we have more than 35 to 40 million tons of bottom ash that is produced per year. Now, this is one example where we were involved constructing a road with pavement quality concrete in Chandrapur near Nagpur, and self-compacting concrete was made by using 50% of sand replaced with bottom ash. All parameters, of course, though there is a slight difference in the properties of fine aggregate, natural sand and the bottom ash. By designing it properly, we were able to make an excellent concrete road which is performing quite well. This is the first trial stretch in the country of a jointed plain concrete pavement using a cost-effective design. Cost also reduces, and the strength is also there. Durability is also satisfied. Therefore, this is just one example. The other one I was telling you about carbon curing and its impact. There are a few more slides which I would not be presenting because of time constraint. This experiment was done at CBRI Roorkee only. This was done by an MTech student who was working with me from Bangalore. He was sent to CBRI for his project work, and there he has used carbon dioxide and carbon curing of concrete with carbon dioxide. Even if you cannot see the numbers, do not worry about it. 4 hours and 8 hours carbon curing of this produces definitely gives higher strength in concrete. Therefore, now the focus is more on carbon dioxide capturing. Any material that releases carbon dioxide at one stage of its production would definitely would welcome its use at the other stage. Therefore, carbon curing is gaining importance in the coming days. You will see more and more examples of this. And the last parameter is to optimize the concrete through efficient design. We all know, our professors in teaching strength of materials have told us that compared to the capacity of a simply supported beam, the bending moment that is caused due to the different kinds of loads in a simply supported beam, compare it with arches. Arches always produce least bending moment. Therefore, arch is always a better form of structural member compared to the beams. Therefore, we need to examine what are the alternate ways of doing structural design to ensure that concrete carbon dioxide emissions are reduced. Therefore, these are all different alternative designs we can think of for as far as the structural forms are concerned for multi-storied buildings, etc. RCC structures with infill walls is the normally used construction, and RC shell structure, the entire RC shell structure where the whole structure works as a RC shell is another thing, and reinforced concrete with non-structural walls with different kinds of low carbon emission materials. From specification-based construction, the country is now moving towards performance-based construction. Now, one or two examples I would give you. As far as roads are concerned, concrete roads are concerned, there are two different codes which have come in recent times. One is for the short panel concrete roads, and another is white topping. The difference between these two is white topping is a composite pavement where already a bitumen road exists. Over that, we are putting a concrete layer. Therefore, it is a composite pavement. The thickness of that would be only about 150 millimeters. Normally, if you design it as a new concrete road, it will be about 300 millimeters. This is only about 150 millimeters from the structural design point of view. Now, certain stretches of now the short panel concrete roads IRC SP 140 is a very recent code which has come, and using that policy by making grooves, by cutting grooves at a shorter interval of 1 to 1.2 meters, we are reducing the span, and reducing the span would naturally reduce the bending moment and therefore reduce the cross section. Again, instead of 300 millimeters, we get 220, 230 millimeters. That is an alternate form of design. Now, precast concrete roads are also becoming popular in our country. Already, Ultratech was also involved in the construction of 4 such roads, precast concrete roads in Nagpur, Amravati, and also Bangalore. And compared to cast in situ concrete construction, precast concrete roads are much better in terms of strength and durability, as well as in terms of the total thickness that we would get. Therefore, these are all the alternate technologies we have, and we all know this how ultra high performance concrete is ideal for long span bridges. It is just coming up in the country. Few bridges have been constructed, and going ahead, I am sure more and more such structures and examples would be available to us. These are all different ways of doing this. Just one example I'll show you, high performance concrete specification based construction I was mentioning. This is one such of the One World Trade Center where the requirement of concrete was M80 to M90 for the first 40 floors, and after that it was 60 to 70 MPa. Please note just one point here. This was designed with a cement content of just 236 kgs of cement per meter cube of concrete. But another thing we should note is that this is designed for not 28 days strength, but 56 days strength. There were performance requirements like the slump flow was fixed at 600 to minimum 600 mm slump, and ability to pump at least 15 floors. Pumpability of concrete was very important, and maximum heat of hydration was also fixed. Therefore, even with all these considerations, adding more supplementary cementitious materials and going in for not just 28 days strength, but 56 days strength, at least for structures where we don't expect the loads to operate right from the first month itself. In such cases, we can definitely optimize with this alternative mixed designs. Therefore, my concluding remark is that the final target is to achieve net zero carbon emission, and the concrete, out of all materials, concrete has the incredible design versatility and flexibility, and structural engineering and concrete technology need to be reoriented in our education as well as in upskilling. Now, our students need to study what is ECF and global warming potential. And with all this, when we are making all this, a very, very important factor is the need to guard concrete construction so that concrete is neither misused or abused. This is one thing that we need to take care of. And housing and roads, they form the bulk of the structures to achieve net zero concrete construction. So with this, I thank you all for your patience. Thank you very much.
Thank you, Dr. V. Ramachandra, for nicely elaborating for decarbonizations of constructions industry. Next speaker is climate resilient precast building constructions by Dr. Y.P. Kazle. He's from BG Sirke, but unfortunately he was stuck up. So Dr. Ajay Chaurasia is going to make a presentations of Dr. Yogesh P. Kajle. So Dr. Ajay Chaurasia may proceed.
Slide visible? Slide visible?
Yes, yes. Yes, visible. Huh? Yes, visible. Yeah, go ahead.
Yeah. So, greetings to all the distinguished guests. It is my pleasant duty to present on behalf of Dr. Y.P. Kajle, Senior Vice President of BG Shirke Construction Technology Private Limited, Pune. So, which is basically a very leading company in India. And whenever you talk about precast construction in building sectors is concerned. So the topic of the presentation is climate resilient precast building technologies. So this particular topic is an extension to the whatever has been delivered in the previous speakers. So when you talk about the climate resiliency for the habitats building, particularly as such. So BG Shirke Construction Technology Private Limited is a company who is acting as a turnkey service provider, which takes up the project on a turnkey basis, right from planning, designing, in fact, manufacturing of the buildings and building components and executions, including the defect liability period and maintenance. So whenever you talk about the climate resiliency, so thermal comfort is very, very important apart from the five different T nets, that is safety, serviceability, durability, aesthetics, and economic is concerned. So particularly when you talk about the resiliency with the climate comfort, so precast construction is always a questionnaire from resiliency point of view, particularly seismic aspects. So precast, in contrast, when you talk about the precast constructions, it is not for the India as such, because since thousands of years, the technology was implemented in indirect sense. So these are some of the leading examples of prefabricated constructions, but not only the RCC, but in stone and masonry and other things. So, but whatever has been constructed in past, so that has embedded climate resiliency into it. Whenever you talk about the precast constructions in the history, whatever India has made so far. So in the modern concepts, when you talk about the manufacturing of the buildings, so definitely precast has to take a role, because there is a huge demand of housing system in India. And if we adopt the conventional construction technologies, we will be unable to meet out the demand. And at the same time, the demand in the present is getting accumulated. To address this issue, the precast 3S precast system was developed. So this particular system was the BG Shirke Construction Technology Private Limited has initiated its initial work on the component level since 1970s. Over the year, they have evolved different aspects of the building from material level to the system level. And while doing so, they have kept proper attention on strength, safety, speed and sustainability. So sustainability is very, very important whenever you talk about precast construction. So for that purpose, they are making extensive use of best product, particularly the GGBS, flash, so that the green concept is embedded within it, and CO2 impregnations or CO2 footprint is reduced. At the same time, whenever such kind of constructions are taken up, so the industry or factory for manufacturing of its units and system level components is installed at the very close to the site, so that the unnecessary transportation and other aspects are addressed timely. So this is the basically about the system, so that it is very clear that the precast technology is very much pertinent from climate resilience point of view, and all robustness have been embedded within this. But now the question remains unanswered so far globally about its seismic performance. So for that purpose, BG Shirke has initiated from time to time from component level testing to the system level testing. In 1970s, during its inception at CSIR CBRI as well as at IIT Mumbai, initially the tests were made on the precast components like beams and slabs. That was only for the gravity loads. Over the years, that was conducted on the precast systems on gravity load again. Later on in 2010, in CBRI, the test was conducted on the full scale level under quasi-static condition to evaluate the seismic performance of such buildings at a system level, wherein very proactive results or very good results have been obtained. At this, in parallel, the system twin RC frame twin system has also been evolved, so that the proper connection between the RC shear walls and RC hollow columns is made. So that has also been tested whenever it is placed in basements or in upper floors, not only from the lateral load resistance point of view, but also the out of plane load resistance point of view. In order to check the repeatability of the tests, again, the tests were repeated at MNIT Jaipur, wherein the tests were performed on the 3-story precast RC structures, wherein the frame was made in different plans, different rooms, and different alternative arrangements have been carried out in terms of the 4 rooms with infill walls, 2 rooms with infill walls when the load is applied in major direction and minor directions, and and it was observed that that the simulation should be made for the still plus 30-story or 22-story building for residential purpose. Interestingly, the very good comparison of the results have been observed even in the repeatability test, which was conducted at CBRI as well as at MNIT. So that basically showcases the robustness of the building system of 3S. And using this particular technologies, the technology is widely adopted in India, wherein around 40,000 plus buildings have been constructed using this technology. So in short, I should sum up that the technology, even if it is a precast technology, it is addressing the basic needs of the present and future generation, including the robustness and climate resiliency. And with this kind of a good legacy, it can be implemented on a pan-India basis or across the country. However, the company is open for 4 Cs as mentioned in this particular, which was the basic theme of this particular session. So you are always welcome to collaborate, converge in this with the BG Shirke Construction Technology Limited as well, from climate resiliency and sustainability point of view. Thank you so much for your kind attention. Thank you.
Thank you, Ajay, for taking presentation on behalf of BG Sirke and that YP Kazle, being he's stuck up in Mumbai somewhere where he was not getting a signals or Wi-Fi. So I'd like to request our honorable director, sir, to sum up the this session as a chair of these sessions. So, director, sir.
Good evening, everyone. Once again, I hope I'm audible. Yeah, so we had a wonderful session with 5 presentations. So first one being by Dr. Ajay Chaurasia, and followed by Professor S.K. Singh, and then Manish Mudgalji, and Dr. Ramchandraji, and then Dr. Kajle's presentation given by Dr. Ajay Chaurasia. And in fact, I would like to reiterate almost all the presenters have stressed the need for for bringing out the climate resiliency as well as new technologies from the point of view of materials, architecture, and thermal comfort, and new technologies have to be tested before they are implemented on the field. So overall, that is a session because we have lost time. So I'm not taking much time to summarize. So with this, I'll hand over session back to Rama Bansal madam.
Satija ji, please.
Yes, sir.
Yeah, please sum up the things.
Thank you, sir. Thank you. So I think there are not any questions because I have not seen any hand raised or anything in chat. I thank our chair, Dr. Anandavali and Dr. Pradeep. Thank you very much, sir, for chairing the session. And all the presentations are really good. And these all recordings are available on YouTube as well as they are available on the SSUNGA website also. They will share the link with us. So there was some technical glitch in the starting. So maybe few people have not able to join. So we will share the recording link with them. Thank you very much.
Okay.
Thank you, sir. Thank you.
Yeah. Thank you. Thank you so much.